All right, today we're going to dig into a machine that's both seriously ancient and incredibly powerful. It's a real old school giant of grinding technology that solves a problem that's, well, surprisingly tough. Let's get right into it. I mean, really think about that for a second. How do you pulverize something like tough, fibrous tree bark? Or what about incredibly dense seeds? A hammer's not going to cut it, and your kitchen blender would probably just smoke and die. So, what's the answer when you need to crush something that seems, well, uncrushable?
Well, the solution has actually been around for centuries, and its genius is just how simple it is. It's called the Edge Runner Mill, and it absolutely masters the art of pulverizing things through pure, awesome brute force.
So, how does this thing actually pull it off? How does it succeed where other machines fail? Well, it's not just about being heavy. The real secret is in the physics. It's all about two different forces working together in this perfect, kind of destructive harmony. Okay, so the first principle is pretty straightforward. It's called compression. This is just raw, crushing power. Just picture a massive, super heavy wheel rolling over something. That immense downward pressure, that's compression. It's the powerful stomp that gets the whole breaking down process started. The compression, that's only half the story. The second principle, and this is where it gets really clever, is called attrition. This is all about shearing force. See, as that heavy wheel rolls, it isn't just pressing straight down. It's also creating this twisting, scraping motion. This makes all the little particles rub against each other and the grinding surface, basically tearing each other apart. It's this grinding, shearing force that works right alongside the compression. So there you have it, the 1-2 punch of the Edge Runner Mill. First, you get that vertical stump from compression, which just shatters the material's structure. And right after that, you get the horizontal twist from attrition, which shears all those little pieces into even finer particles. It's this exact combination that makes the mill so unbelievably effective. Okay, so we get the physics, right? But what does this thing actually look like? What are the key parts that make up this grinding giant? Let's kind of build one in our heads, piece by piece. All right, it all starts with the foundation. For this mill, that's a big, circular, and pretty shallow pan or bed. It has to be incredibly tough to handle all that pressure, so you'll see them made of something super durable, like solid granite or heavy-duty metal. Now for the part that does all the work. We're talking two massive, super heavy wheels that are mounted upright on a single horizontal axle. These guys are the edge runners, and yeah, all that weight, that's where you get that crushing compression from. Okay, but how do these things actually move around? Well, there's a central vertical shaft that connects right to the middle of that axle. When that main shaft starts to turn, and this could be from a motor or even an animal in the old days, it makes the whole wheel setup spin around that circular bed. Kind of like planets going around the sun, you know? And there's one last little detail that's actually super important for making it work well. As the wheels roll, they tend to push the material out to the sides. So to fix that, you've got these scrapers attached inside the bed. And their job is super simple, but absolutely essential. They just keep pushing everything back into the path of the wheels, making sure nothing can escape the grind. All right, so we've got our mill built, we know the forces at play. Let's fire this thing up and see how it all comes together in action, from beginning to end. The whole process is this really elegant, simple loop. First, you just load the material into the bed. Then you kick on the drive, and those heavy wheels start their slow, powerful rotation. With every single pass, they're crushing and shearing the material. The scrapers do their job, pushing everything back under the wheels, and that cycle just keeps going. Stomp, twist, scrape, and repeat. It goes on and on until you get exactly the particle size you're looking for. Now, I know what you might be thinking. This sounds like some really old tech, right? But the thing is, it's still surprisingly relevant. You'd actually be surprised where you can find these things working today. This mill is a workhorse, especially in industries that deal with tough, natural stuff. So think about pharmaceuticals and herbal medicine, where it's perfect for grinding up dense roots and fibrous barks. But it's also great for mixing things, like creating really uniform ointments and pastes. Basically, if you need to break down something stubborn and fibrous, this old-school design is still one of the best tools for the job. So what's the verdict here? What's the final takeaway on the Edge Runner Mill? I mean, it's powerful, it's simple, but it's definitely not perfect. Let's break down the pros and cons. So on the good side, its design is super simple. That makes it easy to run and easy to fix. It can handle wet grinding just as well as dry grinding, and like we've been saying, it's the champion when it comes to tough, fibrous materials. But, on the other hand, it's not exactly what you'd call efficient. Not compared to modern high-speed mills anyway. All that grinding, well, it causes a ton of wear and tear on the surfaces, and these things are huge. They take up a massive amount of floor space.
And all this kind of leaves us with a really interesting question, doesn't it? In our world of high-tech, super precise machines, the Edge Runner Mill feels like something from another time. It's not fast, it's not precise, but it is incredibly good and reliable at its one single job, crushing the stuff that nothing else can. So it really makes you think, where else in our world does a simple, tough, brute force design still come out on top? Something to chew on. Thanks for tuning in.